All right, sometimes you will be solving problems where you do not have the period of time during which acceleration took place. And technically, you can find time if you know your acceleration and two velocities. But that would mean an extra step. In this particular example, I'm trying to figure out the length of the runway on a ship that carries aircrafts. I know that my aircraft will start at 0 from rest, and it will need to reach a certain velocity for takeoff in order for the air to be able to provide that lifting force for the plane to actually, get airbound. So how do I figure out the length of this runway? I can go the long way. I can take my acceleration, my two velocities, initial and final, figure out the delta t, then go ahead and that plus that over 2 times delta t will give me delta x. However, there's actually a shorter way, and the formula that is used is called velocity squared because actually both velocities, initial and final, will end up being squared in that formula. So I'm going to show you how to derive this from scratch. And the two formulas that you scratch are the formula for acceleration. And as you see, I'm color coding this. I'm figuring out delta t from here is going to be v final minus v initial over acceleration. The reason why I am highlighting delta t is that is ultimately what I'm trying to kick out of here. I'm trying to eliminate the need to find the period of time during which my velocity changed. I know the change of velocity, I know acceleration, and I need to find displacement, or either one of those. So acceleration to velocity is displacement, and I'm trying to get rid of time, so I don't want to find the time. And so the second equation that you're going to use is the equation for displacement. Displacement equals v initial plus v final over 2, which is average velocity times delta t. Again, I'm trying to eliminate delta t, so therefore I'm going to rearrange this formula to get delta t. Delta t is going to be 2, so this goes upstairs, 2 delta x's over the sum of velocities. So since both these guys are expressions for delta t, I'm going to set them equal to each other and then cross multiply. So I cross multiply, and hopefully you recognize that this is a FOIL, and it FOILs to v final minus v initial. Both of them are squared. And on the other side we have two accelerations delta x. The conventional form of this formula is v final squared equals v initial squared plus 2 acceleration delta x. So again, when you're quizzed on deriving these two formulas, you are given the formula for acceleration, you are given the formula for displacement. You tweak them a little bit and you end up with this formula. So there you go. Again, this formula you would use when you know initial and final velocities, acceleration, and you need to find displacement. Or maybe you know displacement, you know two velocities, you need to find acceleration. Anything is possible. You can have v final, acceleration, delta x, you need to find initial velocity. So again, right here you do not have delta t. In the previous formula we did not have v final. It depends upon what is given in your data, in your problem, and what you're looking for. So there you go.